Hello everyone, so welcome back to Ronnie Explains. In this video I'm going to take you through the process of designing a circuit of a parallel multiplier, and on your screen you see that we have the complete design that we expect to have at the end of this video. We have some hexadecimal switches here labeled A and B, then we have the sub-design of this multiplier, and then we have some LEDs that give us the extra bits which are not being displayed as results. Then we have the hexadecimal display that has been connected to this sub-design, where if we multiply any two numbers, then we are able to see our results here. For example, what we are seeing currently is a multiplication of 2 and 4 to give us 8, but we can try other numbers. For example, if you multiply 5 and 1, then you get 5, or 1 times 0, you get 0. So let's start working it out. In this Google Sheet, I'm simply going to show you a cool way of doing multiplication. Normal multiplication of decimal numbers, for instance, if we have a number of like 12 multiplied by 11, then this is how we do the multiplication. The multiplication is done, we say 1 times 2 gives us 2, and then 1 times 1 we get 1, then 1 times 2 here we get 2 and we write down here, and then 1 times 1 we get 1 and we write it here. Then finally what we do is we do the addition of these numbers, so that here 2 plus nothing here we get 2, and then 1 plus 2 we get 3, and 1 plus nothing here we get 1. So finally we end up that our answer becomes 132. The same thing we can do with binary multiplication. Now, if at all we're going to do multiplication for a 3-bit, then this is what's going to happen. For instance, we have 1, 0, 1 multiplied by 1, 1, 0. So if we have this, so this is what's going to happen. 0 times 1 is 0, 0 times 0 is 0, then 0 times 1 is 0. 1 times 1 is 1, and we write that 1 here. 1 times 0 is 0, so we write that 0 here, and 1 times 1 is 1. Then finally 1 times 1 is 1, 1 times 0 is 0, and 1 times 1 is 1. Then we do addition of this, and 0 plus nothing here we get 0, 0 plus 1 plus nothing we get 1, then 1 plus 0 plus 0 we get 1, and 1 plus 0 we get 1, and 1 plus nothing here we get 1. So at the end of the day, the multiplication of 101 and 110 is going to give us 11110. So that's how we do that multiplication. Now we have to translate this concept here into a circuit. So here we are going to have some values beginning from this other side. So we'll have A0, then here we'll have A1, then here we'll have A2. So we have 3 bits here, and down here we're also going to have 3 bits. So we can talk about B0, B0, then we can have B1, then we can have B2. So if we're going to multiply this here, then this is what's going to happen. We're going to say A0 multiplied by B0. And just like we know, if we're multiplying A0 and B0, then it means that down here we are going to have A0, B0, A0, B0. Now the reason is because this is an AND gate. If we multiply this together, then we're combining them using an AND gate, and that's why we have A0, B0 here. But all these bits that we have here must be multiplied by each of the bits that we have in the second row. So if we have A0, B0 here, the next one will be A1, B0. So we'll have A1, B0, then the last one will be A2, B0. So here we'll have A2, B0. Then we move to the next one, which is B1. So B1 also gets multiplied by all the bits that we have on top here. So up here, we are going to have A0, B1, A0, B1. Then we have A1, B1, B1. Then finally, we have A2, B1. Then the last one, we have a multiplication with the B2 part of it multiplied by every single bit that is up here. So we say this times this is going to be A0, B2. So this is A0, B2. Then here we have A1, B2, A1, B2, and finally we are going to have A2, B2. Then we do addition of this. So the addition, this is going to be added to nothing plus nothing, and we are going to get the result here. So whatever we're going to get here is going to be the first product. We are going to call it P0. Then here we are going to have P1. Then here we're going to have P2. And here we are going to have P3. Then over here we're going to have P4. Now, if we have P4 here, what's going to happen is that we also have some carry out from the addition of this column, and that carry out will be carried to the next column, and that's why we're going to have P5 in the very final end. So a total of 6 bits as the result. Now, 6 bits as the result, and we know that an hexadecimal display can only display numbers from number 0 up to number F. That means that a maximum of 4 bits. So in the results, because you're going to use an hexadecimal display in our circuit design, it means that our result should start from here up to here. So because this is what's supposed to be giving us our result, P4 and P5 are going to be extra bits, and we are going to represent them using some light emitting diodes. So basically this is what's going to happen. So this is going to be added to nothing, but here we're going to add 2 of them. We're going to add this, and because we're adding only 2 variables, in this case A1, B0 and A0, B1, it means you're going to need a half adder in this point. Then here, the carry out of this column here is going to be added to these first 2, and that's why in this point we're going to need a full adder, and then later on that's going to be added to the final one, which is a half adder. Then the result of this addition, the carry out, is going to be carried to this next column, and we are going to be adding 3 variables, and that's why we'll need a full adder here. And then the result of this will be carried to the next column, and that's why here we're going to need a half adder, and then finally the carry out from this point is going to be brought to the next column, and it will be added to nothing, so it will simply be dropped down here as P5. So I will launch my software and then do some few setups. Instant labels and port labels checked, then view magnetic grid 1/8. I'll also use a zoom out of 0.7. Here I'll begin by creating a half adder, and that's why I'll create 2 I-pin switches. So I'll have that and that. They're a little bit small, so I'll have to zoom this out. So zoom region, I'll zoom this. So the name of this is A and the name of this is B, just some 2 random variables. Over here I'll create an XOR gate, so it's a 2 input, so I'll have it here. and I'll connect this to this and also connect that to that, then create some output LED on this side, and I can name it as sum, and then connect this and this. The name of this is going to be A XOR B. I will also need an AND gate down here, so a 2-input AND gate that's going to be AB, and then I'll add a wire segment here, and then for B also add this wire segment. Then I'll create an output LED that shows me the carry out this, and name it as carry out. So then I also connect that. So this is the half adder. For Control plus F to view it in full mode. This is a half adder that we have. Let me save this in a new folder and call this new folder Multiplier. Open the new folder and then save this as half adder. So maybe just say ha.hds because that's extension. Then I'll come here and open a new one. So new, and then create a full adder very first. So I'll create IO switch, have 3 of them. The name of this is A, name of this is B, and then the name of this is C. Over here I'll create some XOR gates. So I'll have the first one here. Then I'll also have the second one here. Then connect this, connect that, connect this here, and then connect this last one here. Maybe create an IO output LED, then connect that. I know this is XOR B XOR C, and the name of this is A XOR B. So then over here have some 3 AND gates, so create AND gates, a 2-input AND gates. So I'll have 1, 2, and 3. The name of this is AB, then the name of this is AC, and the name of this is BC. Yep. So this is how it looks like so far. I should connect this. So AB, I'll begin by connecting A. I'll add a wire segment and connect this, and also B is here. Then AC, I'll come here, add this. So then for that's A, then C is this. Then for BC, we have this, add this wire segment, this B, and then we have C here. Then I can have an OR gate, so create OR gate, but it's a 3-input OR gate, and then I'll have it somewhere there, and then connect all the wires. And I can copy this and have it here, the name of this will be carry out. So this the full adder. Then I can save this, Control plus S, and save it as full adder. So now what we really need to do is to begin the design process. So I will come here, then I will create IO, then IPin switch, and it's going to be here. The name is going to be B0. I can put this window here and have this one on this other side so that we cross-check how everything is going to be worked out. So we are beginning with B0. B0 should be multiplied by everything that we have on top here. So B0 multiplied by everything before going to B1, then finally B2. So that's why I've created B0 here first. Then now the next thing is to have both A2, A1, and A0 on this other side. I want to create a very big space for that because the design is going to be a very big design. So that's why on this side, I will create IO IPin switch. Then now what I need to do is to simply do the multiplication. And remember, the multiplication, we do it using the AND gate. So I can say Control plus F. Now this is what we have. So I do the multiplication by simply using the AND gates. I have the first AND gate is going to be here. Then I have the next one here. And I have another one here. So this one here is going to be A0, B0, just like this one. This is going to be here. So I will name this as A0, B0. Then this one, I'll name it as A1, B0 because of this here. So this is going to be A1, B0. Then this is going to be A2, B0 because this is this one, this part here is this. Now I need to connect all the this input A input switches to this. So I'll connect that, then I connect this, and then I connect this. Then on this side, I will also work around my way with this here. I will have this up to here, and then do the connection of this. So add this wire segment here because all of them need to be multiplied. Then also here, add this wire segment, connect it here, and then that's done. So after having done that, I need to do now the next multiplication. For now, I'm going to leave these outputs without any connections because the design is still a work in progress. So I need to also include the second B input switch, which is now the B1. So I'll just copy this. I'll move it down a bit. So I'll copy this and put it somewhere down here. And the name of this is going to be A0B1. and that's because of this. This is A0, B1. Then the next one is A1, B1. So that's why I'll copy this and put it here, and it's going to be A1, B1. And now the other one on this other side, maybe I can copy this also and put it this side. And the name of this will be A2B1 because it's on this row. So A2B1. Okay. So I will have this connected to all of them. So this will be here. So B1 should be connected to every single one of them. So I'll add a wire segment and connect it this way. Now the A part of it should also be connected. So I have A0 here and there is a A0 here. So it means I can add a wire segment like this and connect this A0 to this point here. Then I can also have this A1. So I add a wire segment here. And connect this. Then for this A2, I can also have this, add this wire segment, be up to there, and connect it to this one here. So A2, A1, and A0, all of them have been connected. Now we're going to the third row, and just so you know that we can be adding things as we move. Because in the third row, we need to add some few things. We need to do addition of at least what we have already. So we realize that here we don't have anything to add. So that's why we're not going to care about this for now, but we can care about this and this. There are two of them, so that's why down here we'll need a half adder. So I'll right click. Now before I right click and put a subdesign of a half adder here, I'll need to go back and create a symbol of our half adder. So I'll come here and then open. So then I can save this. So save. I can save this one as I can save it as circuit .hds. Now I need to create a sub design of this half adder. So I'll come to edit, then I'll first create its symbol. Then again I can come here, open this full adder also, and then also come to edit and create its symbol. So if I come here and open this circuit, then over here I can right click and create a sub design. Then I can now create a sub design of the half adder. And now this is the sub design. So this sub design of this half adder, I need to put it exactly down here because I want to add A1B0 and A0B1. So it's going to be maybe let me say at this point here. So if I zoom out that region, then this is how it's going to look like. So there's some C out and then this one's. Now what does this mean? It means I'm going to add this here going to add this here, and also I'm going to add it to this. So these two are being added. We are going to have the sum and the C out. Remember, because we are still doing our addition in this, we are still doing addition in the third row, our C out can be carried and added to this third column. And that's why if we take the C out of this and then plus these two variables, then we have a total of 3 variables that are being added in this third column here. So what does that mean? It means that over here we're going to have a full adder. So I'm going to create a subdesign, then I have a full adder subdesign. So this full adder is going to be here. So I can take the C out and have it here being added to this. Then I can add this and this. These two variables, I can also add them right here. So I'll pick this first one like this and put it here. Then I can also pick the second one and then add it over here. So we have this and this plus the carry out of this half adder being added in this full adder. So remember, this also is going to have the C out part of it, and that C out must be added in the next column, which is this, and we only have one variable plus the C out variable, and that makes them 2 variables. And that's the reason why we're going to need a half adder here. So I'll copy this half adder and then I will put it over here. So this C out is going to be added here, and this value is also going to be added in this half adder. Then we have the C out on this other side. Now, because we don't have any other stuff here, we have to be patient and wait for some more variables to accrue on this other side so that we can have this C out being added in this other column, this other side. So that's what we do in the third part of it. So we have combined some essential parts of this circuit. Now the next part that we need to also work with is to create a B2, because you see this a B1, now we need a B2. So I'll copy this and just move some little bit up to, let's say, maybe maybe here. So Control plus F. So far, that's what we are having. I'll create some AND gates for the final part of it, and that's the multiplication of B2 with this B2 with the rest of these values that we have here. So that's why I will create gates, then I will have AND gate to input. The first one will be in line with this. So I'll have this down here. Maybe have it this as 1. Then I'll have this here. Then I'll have the final one on this other side, maybe there. So the names are going to be the names that we have down here. So I can name this as A0B2. Then I can name this as A1B2. And then the last one, I can name it as A2B2. Then now I need to do all the connections. So that's why this B2 needs to be connected to every single one that we have here. So we are going to have this here. Maybe just move it a bit. So I'll move this one to here, and then have all the connections done from this point. So this will be connected here. Then I can connect the rest. So I will add wire segments and connect that. I'll also add a wire segment and connect this. So I need to connect all the A's. So A0 was here. This was a wire for A0. I can add another wire segment over here, or maybe I can remove it from this point. It depends with my preference. So I can add this wire segment here, and then I can connect it at this point. So that's A0. For A1, I have it at this point, so I will add a wire segment here. Like this. Then for A2, which is this one here, I will also have it from this point. So can add that wire segment, and then I can have it at this point here. So all of them have been connected. I need to do the final round of addition. Now what do you realize? You realize that over here we don't have any other thing to add in this column. So in this column we have the addition of the sum that we had in this point and the new variable that has been created here. So that's why the only two that we're adding. So we need a half adder. So I'll copy this and then I'll put it here. So we are going to add this sum here, this sum, and it's going to be added to this variable that we have on this part here. So it's only two things that are being added, but the sum is going to be here, where the C out is going to come out from this point. Now the C out must be added to something. Now if you look at this column, we have the sum here, and this sum should be added to this plus the C out that comes from this one. That's why we need a full adder here. So I'll copy this, and then I'll have it here. So we need the sum here. Then we need this variable here. And then finally we need the C out from this end. So that's what we need. Then we also realize that right now we have this, but this C out that we are having here, this C out should be taken to the next column. If we take this C out to this next column, then down here we also have another C out. This C out will also be taken to the next column. We have two C outs that are being added to this variable, and it means that now we have a total of 3, because we have this variable plus 2 C outs, which is now 3 variables in total, and that's why we're going to need again a full adder. So I'll copy this and then I'll put it somewhere here. So I'm going to have the first C out, which is this. This here as the first one. Then I'll have this variable here. And the last one is going to be this C out that we have here. So that's what we're going to have. So now you realize that we've done all the addition in this circuit. So what is going to happen is we now need the result down here. Now the result that we're going to need, we are going to display it first using some LEDs. So I will create some output LEDs. Now these LEDs are going to be 6 in number, just the same way we saw that in this point we were having like total of 6 results, 6 bits down here. So that's why here we are going to have 1, 2 with, let's say, 3, 4, 5, and 6. Maybe just move this a bit and put it somewhere here. I can give it the names, the same names that we had here. So I can call this P0, then name this as P1, name this as P2, name this as P3, and name this as P4, and finally this here as P5. So that's what we have. Now remember, we have a C out here, and this C out is supposed to be carried to the next and being added to nothing because we don't have any other thing that should be added to here. So that's the reason why this C out here is going to be the very last bit on this other side. So that's why we bring it here and then we connect it to this. But this is P4, which means that it is the addition, the final sum of this column, and that's why we are going to take this sum and then we connect it to this over here. Then in this column, the final sum is going to be this, so we connect this sum down here. Then in this column, we have this sum here that we connect to this LED that we have here. And then here, this sum is also going to be connected to this LED down here. So we have this being connected here. And now the last one is this, which was not being added to anything. So it should also be connected to every other thing that we have on this side. So now this is the final design that we have, and whatever we are having here as a circuit is simply what we worked out on this other side. So now we have to create a very big sub-design for this, and that sub-design, we are going to represent it in our very final work. So I will have to create a symbol for this, so I will come to edit and create symbol. Then I'll have to save this, so Control+S, so everything has been saved again. Then I come to file and open a new one. So I'll create the very last sub-design. So create sub-design, and then I go for circuit. So I'll zoom this. So this is what we are having. So if you look at this, we have to give it some hexadecimal switches on this other side. So I'll create IO, then hexadecimal switch. but two of them, so I'll have 1 and 2. Then on this other side, I'll create an hexadecimal display. So I'll have IO, then hexadecimal display. So I'll have it somewhere here. Then I'll also create some LEDs that shows me the extra bits. So I'll create IO, then output LED. In this case, I can just have LEDs because this is my final work. So I'll have one there and another one here. So I'll need to do some few labeling. The first one here, I will name this as X1, meaning extra bit 1, and I'll name this as X2. That's extra bit 2. Then I will do some few connections. This will need to be connected to the very top one, which is this. Then this needs to be connected to this here. Then I'll also do some connection down here. So I'll connect this, then this here, this, and then connect this. Then I also need to connect this other side. So I'll name this as A, meaning a hexadecimal switch, and then I'll name this second one as B. Then I will connect all A's to the A's and B's to the B's. So this 0 will be connected to the A0 here. Then 1 connected to this A1, 2 connected to the A2. We are doing a 3 by 3 multiplication, a 3 bits by 3 bits multiplication. So it's not a 4 by 4, and that is the reason why we are not connecting this 3 to this sub-design here. So over here again for the B, 0 to be connected to base 0. So I'll need this here. Then 1 to be connected to this, and then 2 to be connected to this. Again, we are not connecting 3 because it's a 3 by 3. So what we can do, we can create some input switches, but we should always put them off because just to connect the open ports. So I'll create IO, then IPin switch. So I will create the first one here and create another one here. So I'll name this as 3 and then name this as 3. Okay, name this as I1 and name this as I2. So this will be connected here and this will be connected here. This will be connected here. So throughout the multiplication, these 2 pins should always be off. We should never let any current to flow through them because we are multiplying a 3 bit by 3 bit. Now, the name of this sub-design is going to be a parallel multiplier. And that's what we have. So what I can do is to do some tests to see how it works. So I'll control plus F, then activate everything. I'll activate this, and I also activate that and activate this. Now we need to multiply any two numbers. We can begin maybe by 3 times 2. So 3 times 2 gives us 6. And maybe another trial, maybe you can try 5 times 2, which is 10, and 10 is represented by a, so 5. So reset this back to 0, then 5 times 2 is 10, which is a. So I hope you found this video helpful. If you did, please give it a thumbs up. Consider subscribing, and you can share it with your friends. Thank you, and see you in my next video.